Good morning and welcome to the webinar, and good afternoon to our participants from China. This is the second webinar in the series organized by China Europe Water Platform, together with our partners from Aquatech Shanghai, from IWA China, from EU SME Center. And we are very happy to have this meeting and this opportunity today. We are in a series of webinars where we are looking into the urban water field, and we're looking into a field which is characterized by quite a number of challenges, but also opportunities coming up. The challenges are quite well known to all of you. It is several areas with water scarcity, several areas with huge water quality problems, and is climate change coming up and enforcing and strengthening in a negative manner all of these challenges. I'll take you through a few slides before we will go into the list of speakers, and it will be that. So as you can see, several characteristics are shared between China and Europe. In both areas, we will have retrofitting of old urban areas with quite old infrastructure. In China as well, we will have the new urban areas with an expected increase in urbanization coming up. The key characteristics are huge levels
I'm sorry, Henrik. We don't
Yes?
see your screen.
Ah.
Hello?
I'm sorry, hopefully, hopefully it's coming up now.
Yes.
So the key characteristics for the urban water infrastructure are huge levels of water leakages in quite many pipe systems. It's wastewater treatment plants who are not designed for top modern functioning, including resource recovery. It's digitalization only fully implemented in few places. And in quite many places, we don't have the key features of urban water management and infrastructure integrated in the same decision making. And all of that calls for a range of challenges and potentials which we cannot fully address. Today's meeting will discuss these. We will look into to which extent that state-of-the-art solutions are actually well, they're available for the market, but are they requested by the market? And what might be the difference between procuring state-of-the-art solutions or procuring bulk solutions? We will see that digitalization cannot be necessarily achieved at full scale. What would that mean? And we will look into what are the barriers at governance and various economic framework situations. So with a lot of challenges already existing and many coming up, are the existing solutions sufficient, or do we need to look into innovating these even further? How much of the digitalization potential can be achieved? And one of the features here, if we cannot organize data collection and data sharing in efficient manners, we will not get the full potential of digitalization. We will look into the economic situation, the cross-sector valuing, and we will have to, in many places, face that we will not have abundance of finances available, and therefore we should be able to look into where do we get most, basically where most water for the money, including what does the long-term horizon and the long-term economic profile based on true cost of ownership, what does it look like? So with these few words, I will, in a few seconds, pass on the floor to Yuan Xiaoshu from China Water Risk, who will look even further into the economic perspectives of water. One small detail for those of you who have not registered yet, I would urge you to make the registration also after the meeting has taken place, because it will allow me to send you the feedback scheme and also allow me to keep you informed directly about upcoming activities and information which will be available. We have our full scheme here. We have some technical problems with the first speaker, Xiaochang Wang from IWA. So we will change the sequence and start with Yuan Xiaoshu. But otherwise, the scheme here, which all of you should have achieved, will be what we're using. So with this, I will pass on the floor to Yuan Xiaoshu, and hope you will all have a good webinar. Please use the chat for comments and questions.
And hello.
You're clear.
Hello. Hello, Henry. Can you hear me?
Hi, you're clear. You're clear.
Okay. Okay. Good morning. And can you see my screen?
Yes.
Okay. Good morning and good afternoon. Thanks for inviting me to give this speech on the water challenges of China right now. I'll go through with the slides. First, I'm going to make a short introduction about about us, CWR. We are a think tank based in Hong Kong, focusing on water, and we've written plenty of reports, and we've done a lot of research for financial institutions and the corporates and the government on water issues like water scarcity and water risk and water pollution, something like that. Here are our reports, and you're welcome to scan the QR code there, and or go to our website to get all the information you want. So first, let me give the background of China's water challenge. Sorry. Okay. We use a bathtub waternomics indicator as to showcase how much water a country uses and a country has. Like, for example, for US people, they on average, each person uses 21 bathtubs of water a day. That's quite a lot. And the reason that why US people can use that much of water, because it has a lot. It has abundant water resources. Like here, it has 131 bathtubs a day. So they can use 21 and they still have a lot. But for Asian countries like China and India and Iran, they only have like about 20. Like for China, they have 28 bathtubs a day, and for Indian, it only has 20 bathtubs a day. So definitely they can't use water as the US does. They have to find a new way of development for themselves. Here are 4 maps of China, and respectively availability, water stress, groundwater depletion, and water pollution. All these 4 indicators shows China's basic water challenges currently. Let's look at this. Like here, availability, it's red. Water stress is red, and the groundwater depletion is also red, and pollution is also red. This place is called the North China Plain. It's here. And let me just introduce shortly for how to read this map, because there's a water poverty mark, which less than 1,000 cubic meter per capita per annum. Then if your water resource per capita per annum is less than 1,000 cubic meters, then you are marked as gray, like here in Gansu and Liaoning. However, if you are even more water scarce, like if you are under 500 cubic meters per capita per annum, you are marked as red. Like here, Beijing, Tianjin, Hebei, Shanxi, Shandong, Henan, Shanghai. And this 11 provinces, we call it as dry 11. They account for 45% of China's GDP. And this circle is the North China Plain, and the water resource here is 47 bathtubs. So it's quite water scarce. And what's more, about 350 million people living there, and almost 30% of China's GDP is generated from this region. China has very limited resources, like for example, 7% of the water resources, 8% of the arable land. But actually China is producing goods for the world, like 85% of the rare earths is produced in China, and 66% of the chemical fibers, for example, steel, coal, paper, cotton, something like that. Our question is that if China remains in this status, can China still be the global manufacturer? So the Chinese government has also realized this this issue, and so starting from 2011, they have published a series of policies and regulations on water resources. The most famous one is called the 3 red lines, which is 3 red lines respectively for total water used and water quota, and water efficiency and water pollution. Let's see, before 2011, like from 2004 to 2011, China's total water use has been increasing all the time to 610 billion cubic meters in 2011. And that's why the 3 red lines came out at 2011. And after that, in China's 13th five-year plan, and the Chinese government came up with a dual control of water resources. There are 2 aspects. One is for the control of total water use, and 2 is the control of water use intensity, which is also the water use efficiency. So the total water use is supposed to be capped at 670 billion cubic meters by 2020. And there are 2 indicators for water use efficiency. One is water use per 10,000 GDP, and the other is water use per 10,000 value added of industry. They all have a target for 2020, like a reduction from 2015's number. So let's see how it went since China published a series these policies and regulations. The black line is the total water use. We can see like it's declining steadily, especially for this. For dark blue is the industrial water use. It has declined a lot in the past 10 years, and also as well as the agricultural water use. And the water use efficiency actually improved a lot. This is the one of the indicators, water use per 10,000 GDP. It's declining during 13th five-year plan. Now let's talk about the total control of the total water use. So China has an old water use target, which like in 3 red lines, it has target for by 2020, it's 670. By 2030, it's 700 billion cubic meters. And during 13th five-year plan, China issued a new target, which actually it delayed the target from 2020 to 2025. It doesn't mean that China is not confident. It's the opposite. It's actually China has set an stricter target for itself. So in the old target, in 2025, the cap is about 690 billion cubic meters. But now in the new target, the total water use cap has become 670 billion cubic meters. So China is quite confident in meeting all its targets. Let's see how it works, how it worked before. In 2015, China has a cap about 635 billion cubic meters. And this is the actual water use of, the light blue is the actual water use of China. So it's far away from the water use cap. We haven't got the number for 2020 actual water use yet, but if we use 2019's number, it's far away from the 2020 water use cap. So we think that after 2020's number comes out, China will definitely meet the target. Now I'm gonna take a key area as an example to see our waternomic analysis of China, of the relationship between water resources and economy. So this, the detailed analysis is in our report, which can also be obtained on our website. So this is the Yangtze River Economic Belt. It's a large area, including 11 provinces. And it has almost 200 big cities and hundreds of power plants and hydropower plants. And a lot of rice and grown here, and the green dot, as we can see. And also, it accounts for China's over 40% of China's population and 45% of China's GDP. It's very important to China. If we take out YREB, the Yangtze River Economic Belt, to compare it as a country, I can see it has a more population than the US and Indonesia. In terms of GDP, it's larger than Japan and Canada. Apart from this, and this YREB is also very important to the global supply chain. It accounts for over 50% of the global chemical fiber and antimony and tungsten and heavy rare earths, something like that. So this region is very important. However, this region also has a serious water problems. For example, we have based on WRI's water stress map, we've done analysis for different 11 provinces in this region. We can see, like for Zhejiang and Jiangsu and Shanghai, these downstream Yellow River Delta regions, which is the most developed regions in YREB, they have, like for Jiangsu, almost all the regions are in dark red, which is extremely high water stressed. Like for Shanghai, almost all the regions are high water stress. So they're facing severe water problems. We've actually have done a chart here, and this is our waternomic chart. The y-axis is the water use per 10,000 GDP, and the x-axis is the wastewater discharge per 10,000 GDP. So the y-axis means the water use efficiency, and the x-axis means your wastewater treatment efficiency. Like for example, for Shanghai and Jiangsu and Zhejiang, the size of the pie chart means the GDP a province generates. For Shanghai, Jiangsu, and Zhejiang here in this corner, they're actually good performers for their waternomics, because they uses very little water and discharges very little wastewater. But at the same time, they are generating a lot of GDP. For example, for these three provinces, for Jiangxi, Guizhou, and Yunnan, they are generating very little GDP, but meanwhile, they are using a lot of water and discharging a lot of wastewater. So these three provinces need to look their industries and to decide and to pick up some water efficient sectors and to dump some like polluting and water consuming sectors like that. In terms of the water use target, here Jiangsu is definitely the biggest water user. in this region, and it uses a lot of water in agriculture and industry. And also for Jiangsu, and the blue bar is the actual water use of Jiangsu in 2017. And the two red bars are the water use caps for Jiangsu for 2020 and 2030. So in 2017, Jiangsu is still far away from its water targets. And since 2020 number hasn't come out, if it turned out that Jiangsu failed to stay within the caps in 2020, like in future, in 14th five-year plan, Jiangsu may face like pressures, environmental pressures, like for polluting and water consuming companies and corporates, and they may find themselves more risky operating in Jiangsu. And also the same for Anhui, but Anhui's situation is a little better since it's only a little over the cap. And for other provinces, they're fine with their cap. And we think that they would all meet their targets by the end of 2020. So more detailed analysis, we've done that for each of the provinces in the report, and you're welcome to download and read that report. And in total, and it's very important for China, and it will be a target for China to tackle its water problems during its 14th five-year plan. And we think China will make it. That's all. Thanks.
Thank you very much, Yuchan Xiao, for this very comprehensive overview of the water challenges, and also an overview which gave the understanding how the water situation in each city and each utility sums up to these large-scale challenges and problems. We have some technical problems with the anticipated next speaker, but we hope to solve it. So therefore, we will continue instead to Louis Frasca from Aquatech, Portugal. And Louis, you're already on with the screen. So please go ahead with your presentation, and I will give you a signal when there's 1 minute left.
Okay. Good morning. I'm just sharing the presentation. Hi, Henrik. Good morning and good afternoon in China. Good news from Yuan Xiaoshu showed that Chinese regarding China's efforts on water usage. I will present you the Santander example is urban water infrastructure with a mixed, a multi-cross sector approach. Regarding Aguas de Portugal, Aguas de Portugal is a share-owned holding company. It was founded on 1993 with a mission for designing and building and managing water supply and wastewater systems in a framework of economic, social, and environmental sustainability. We cover full cycle of water, mostly on a multi-region and multi-municipalities framework. Most of our companies, they supply bulk water to municipalities who then distribute and they return it as the wastewater, and we treat it and reject it. We have presently 12 companies that cover 80% of our of national mainland, and we have shared service for energy and added value, and also some international companies working in mostly in Africa and Asia. We manage 150 water treatment plants we count 1,135 water intakes, and we operate 970 wastewater treatment plants. Our network pipelines are 16,000 kilometers, and we have 1,700 reservoirs. Regarding the sewage network is 9,465 kilometers. And regarding wastewater and water pumping stations, above 2,500. We offer a wide range of solutions for different contexts. As I've mentioned before, 80% of the Portuguese population is served by our company. We have managed and created 12 water supply and sanitation regional utilities, from highly density urban areas to rural regions, from small decentralized systems to large high-tech and smart systems throughout the Portuguese mainland. Now going to the Águas Santo André case study. It's in the western south part of the country. We have our challenge was industrial solid waste coming from major deep water harbor and a major petrochemical hub. We have the biggest diesel refinery in Europe, which produce highly polluted effluents. And we also have the problem of the emerging dormitory towns and the domestic effluents. All these, especially the major petrochemical hub and the emerging dormitory towns, have a huge, large-scale water demand. So our approach was a multi-cross sector approach. So we have managed in the same company both systems: the drinking water system, we have a segregated groundwater supply, and then we have the full chain of our industry, and we also developed a fully independent industrial water system, which has an independent water source, dam, and dedicated water treatment plan and distribution. We then collect all the wastewater from the urban area and the industrial wastewater from the industry. And we have segregated effluent collection systems, and we treat it in a single urban and industrial wastewater treatment plan, and then we reject it in the ocean by submarine hemisphere. We also run the industrial waste landfill, which collects. We don't collect; we just operate the landfill. From this approach, we have been able to use the high organic loads that the domestic effluent wastewater has with the industrial effluent, which it's up to 70% of total wastewater ingression in the wastewater treatment plan, which lacks of organic load. So we can use the organic loads that the domestic effluent has, and in order to have more efficient treatment and a huge reduction of reagents and chemicals to treat the industrial effluent. So with this multi-cross sector approach, we have reached a higher economy of scales and higher economy of scope. So we have decreased capex and opex for operations during the with this approach. The expected demand increase for industrial water. We are expecting that more industries will come. The harbor is expanding. Rotterdam has reached full capacity in the last year, so we're expecting with this deep water harbor, we are getting more ships as the completion of high-speed railway is going forward, and also the petrochemical plants are expecting to expand their activities here in Sines, and we are expecting the establishment of some hydrogen production plants, and they will demand some reused water for producing green hydrogen, as we have huge incentives on the hydrogen that is produced with reused water, and we are ready to produce. We have made our water demand scenarios and water sources, and we were expecting for up to 10 billion cubic meters per year. We were using the same water source that we're using now, that's the river. And if the increase of water demand reaches 25 billion, we will have to connect to another dam, which is far away. And if it goes further, up to 38 billion, we will need to desalinate water. What happened is the hydric stress on superficial water source, the river, we have some problems with the water in some years, and we have decided to anticipate the Alqueva Dam connection. So I show you, and we have the existing dam, which is supplied by the water through the existing pipeline. This is the green one. It's up to 40 kilometers for the river intake, and we will connect to the Alqueva Dam, which is the biggest artificial water in Europe. And
1 minute, Louis.
Yes, and we are going to build this new pipeline for taking water to our system. And this is the schematics from our drinking water system. It's coming from groundwater boreholes, and the industrial water system on the right is coming from our present dam. So to keep it short on the 8 minutes allocation, this is the case I had presented to you. Thank you. Henrik?
Thank you very much, Louis Feisker, for this interesting case. I'm quite certain we will come back to it when we get to the roundtable discussion in the end of the webinar. We will now move on to the speaker from IWA, Mr. Xiaochang Wang. I hope you are ready. I don't see the picture of Xiaochang Wang among the speakers right now. As it seems like we still don't have the connection, I will instead, Østen Egengren, will you be ready to give your presentation now?
Sure.
Excellent, Østen. Thank you very much.
Well, good morning and good afternoon. I will talk a bit about the water reuse in a circular economy. We've been looking at wastewater in a similar way for more than 100 years. We started here in Sweden to treat the wastewater by connecting it with the sea. So we hope that the sea will do the job. We understood after some years that this is not happening. We got problem out in the sea, so we started to treat. Step by step, you have moved from taking away organic to take away phosphor, to take away nitrogen. And now we are talking a lot about pharmaceutical residues, microplastic. And to be honest, I think even if we are doing a good work, we still, like here in Sweden, we have problem with eutrophication out in the sea because of what we have done during the years. And what is tricky with the ordinary way of thinking, that is to protect environment. At the same time, the better we treat, the more sludge will be produced. So what to do with the sludge? And also we need to recycle the nutrients because we have more population to grow. And it is also a state that we emit a lot of greenhouse gases by running those plants. And I study chemistry myself, and I asked the teacher, how can we know that the water is pure enough? And the answer has been during the years, if you are below this COD, below this BOD, below this phosphor and so on. And that reflects what we think is enough treatment for nature. But if we look at the problem worldwide, we must rethink. Because here we see that with the climate change, the water shortage comes up. Even in Sweden, we have water shortage. Unbelievable that we could get this. No one thought about it 10 years ago. And this is going on and will be even worse in many places because you will have heavy rain and you are not able to collect it good enough. And then you have areas where you will have very little amount of rain. So this means by looking at the map, and you see more detail about the Chinese situation in the former presentations, see there are many, many areas with problems, and they are connected with economic growth, like in China, like in India, like in California. So we must really find better solution to this situation. We have tried now in my research institute to focus on something different. We call it the production facility. We should see the wastewater, whether it comes from the municipality or industry or farmland. You should see it as something valuable. So you should treat it in a way that the water can be reused, that you produce energy and that you produce nutrients. And we've been working in this direction for a long time. We were not funded in the beginning, but now later on we have funding. So this has been possible to scale up. We are running a quite large pilot demo plant here in Sweden. We can run 5 different lines, 4 cubic meter each. In this scale, you can upscale to full scale, which is the idea behind it. So here, the researchers from all over the world can come and do testing and research together with us. For the moment, we have been running the first MBR plant here in Sweden. It will be installed in Stockholm and will be one of the largest in the world. But we have also studied how to treat pharmaceutical residues because we find them everywhere in the wastewater. And you cannot say that you can see a real problem. Some reports says that, but you also understand that it cannot be very good to let out a lot of pharmaceutical residues into the recipient. So now in Sweden, we have the tradition using activated sludge, but we also use SPR. So idea is that after conventional treatment, you add ozone to degrade the pharmaceutical residues and other organics. And then you have a polishing with sand filter and activated carbon. So this is now installed in full scale in 2 cities in Sweden. It is not the legislation because the city want to do it because they don't see why they should not take it away because the price is not so high. And then we found that this water after this treatment reach a quality. So if you just add UV, we see it's possible to reuse to the groundwater. Or it can be used in the agriculture or in the industry, but not for sure, because they must specify the quality criteria they have. And it's very bad in that respect. When I ask industry people, what is the quality that you need? They say the same as before. The same as before has been working for a couple of years. But how do you know that you don't need another quality to have even better production? So this, we must rethink more, that water can be used in one area and then reused in another area. To convince people that treated wastewater is a good way, we produced a beer called Purest together with a local brewery. We took the wastewater from Stockholm, we treated it in the ordinary way, and then we added the final treatment as I described to get rid of pharmaceutical residues. The only problem we got was that the water quality was too good. So we had to add some salt. But this has been sold in 6 Systembolaget shop in Sweden. People think it's quite good. It depends on your own taste, but it shows that it's probably, you can produce beer from wastewater. And the price is very low. The price for 1 bottle of beer is $2 US. The price to treat the water is only 1% of that. So it gives you an idea that more water can be reused. And compared with to produce the fresh water from seawater with reverse osmosis, the energy consumption here is only 20%. The sludge that you are producing must also be taken care of. Biogas is one very good alternative. When you use the sludge, you produce biogas. In Sweden, it is upgraded in many cities as a fuel for the transportation for buses, but even for cars. And this is something that should also be introduced more in China. And we are happy now to study this possibility in the city of Rugao. But then also what is left after the biogas, you must find a way that the nitrogen and phosphor goes back to farmland. Sometimes with the sludge, sometimes maybe you need incineration and then recovery from the ashes. So I will end here by saying that the integrated solution, I think, is the way forward. We must see possibility to reuse wastewater, not only from municipal wastewater treatment plant, but also from industry and from farmland, I would say. So this is my message. Thank you very much.
Thank you, Østen, for bringing us on this journey towards the integrated solutions. Very, very interesting. Without further ado, we will move on to next speaker, Søren Carsten Nielsen. And Søren, you will, I think, if I understood correctly, you will look very much into water leakage problems, right?
Yes, thank you very much for giving us this opportunity to present our approach to reduce non-revenue water. You see my screen now?
Yes, it's fine. Just go into slideshow mode.
Yes. So reduction of non-revenue water is a very important task for the water companies. Loss of drinking water means loss of scarce resources, loss of money, and vulnerability to hygienic problems. But dedicated work on reducing the volume of non-revenue water can lead to less than 10% in the long term. To obtain this goal, a number of appropriate solutions must be implemented. But you can make, it is a fact that in Denmark, the average non-revenue water is reduced to 7% last year in an average for the water companies. Yeah. Behind this schedule, sorry. Behind this presentation is, I'm really sorry about this. I don't know how to stop it. This is very embarrassing. Sorry. Behind this presentation is CEO of LifeCock, Jørgen Würtzner Koch, business developer of Krüger, Søren Carsten Nielsen speaking, and chief assistant of LifeCock, Pai Chen. We have a solution to reduce non-revenue water, which consists of a 6-layer activity plan: online registration, district metered area, leakage detection, pressure management, accurate consumer meters, and pump arrangements. Now, for the first one, online registration, we will install a unit at the entrance to a supply area. And this unit will transmit data every 5 minutes on water pressure and water flow, and every hour on water volume and energy consumption. The transmission goes through the mobile network, and data ends up in a database from where a system, water manager system, can interpret the data and make reports and make, through algorithms, give warnings about leakages. You can also, like shown here with the graph, you can go in and make graphs and study things in details. And you will be able to look at water balances. I will come back to that. Now the second stage is district meter areas. A district meter area is a defined area within the water distribution network. It is closed either by valves or by permanently disconnected pipes. And water coming into the area is metered, as I showed you before. And on the basis of these measurements, it is possible to make a precise water loss analysis. The third stage is leakage detection. It requires trained and dedicated personnel, and it requires access to the right technology and effective planning. And then when data gives indications on something is wrong in an area, you will start leakage detection activities. The fourth layer is pressure management. It will increase comfort, delivering a stable pressure in the critical points. You will save energy as pressure is lowered on an average. You will reduce leakages due to lower pressure, and you minimize the risk of pipe bursts due to more stable pressure. The fifth activity is accurate consumer meters. They should be able to detect even low flows and can be an important in order to reduce commercial losses. Modern inductive meters starts measuring already at 2 liters per hour, where mechanical meters starts at 20 liters per hour. It is worth to consider whether this is beneficial for your area. The last part is pump arrangements, where smooth operation, less pressure fluctuations, and fewer start and stops, and very low energy consumption is a result of a a good pump arrangement. Now I'll look into the water balance for one domestic zone. I have here on the graph here with the blue and red columns. The red columns are the water pumped into the system. You have an area with around 10,000 people. And the blue colors are the water that is accounted for. Now the difference between these, in this case, is 150,000 cubic meters, and it corresponds to 36%. This is the non-revenue water. This is the water not revenued for. Now I can go into to look at the flow pumped into the area. This is based on the 5-minute values, this graph down here. And you will see clearly that we have two big incidents with the leakages. The first one accounts for 66,000 cubic meters, and the second one for 23,000 cubic meters. In general, you have a leakage around 5 cubic meters per hour, sorry. And this counts for 44,000 cubic meters. All in all, you have 73,000, which corresponds to 20%. So the physical losses, they are 20% in the area. And then you can calculate the commercial losses, which are 16%. So reducing non-revenue water has a good business case. For step 1 to 5 in the area we just talked about, the investment will be around 1 million CNI to reduce about 80,000 cubic meters per year. With a production cost around 2 to 3 CNI, you will have a reduced cost of 200,000 CNI. So the return on investment will be 5 years. After 2 years, when training are finalized and investments in one area, it will be reduced. So you can expect to decrease it to 4 years. Now, the benefits will not only be economical, but it will also be a risk for contamination of the drinking water. When a leak makes contact between water and soil, you risk to contaminate the water. You will have lower environmental impact, long lifetime for the network, lower energy consumption, and leakage will slow down the leakage. When you don't have enough water in the area, it will slow down the development of the city. There are some barriers. Low tariffs on water and energy is a barrier, as I have found it in China. And the work for lower non-revenue water requires organizational changes. You will involve many departments in in an organization, in a normal water organization. And all consequences of water recovery are not included in the cost of water. You have an ecological consequence when you draw too much water from the system, from the nature. And then the last thing is that the work with technology for lower non-revenue water has not the same potent as change pipe projects. So we see a tendency that change of pipes is more popular than non-revenue water projects. So thank you very much for your attention. This is what my speech, this will conclude my speech.
Thank you very much, Søren, and thank you very much also for summarizing the barriers in the end of your interesting presentation. This is something we will come back to at our roundtable in the end of the webinar. We will now have the pleasure to be able to invite Mr. Xiaoqiang Wang from IWA to take the floor, and I think the speakers, the administrators will help you with getting through your slides. So please, Xiaoqiang Wang, let's have your presentation. I think you need to take your microphone down to your mouth on your headset.
Hello, can you hear me now?
Yes, excellent, thank you.
Oh, okay, yeah, thank you so much. I'm so sorry for the trouble with my PC. So now I want to share my screen. Does it work? Hello, does it work with my screen?
Not yet.
We can't see your screen.
You can't see my screen. Okay, so I will see what's the problem. So here, because here I used, okay. Is it okay now?
No, I can share your presentation as well.
Oh,
Would you
okay,
like that?
Okay. Oh, okay. Yes, please. So can you help me to share the screen with our audience? Yeah.
See you? Yeah.
Okay. So can I start? Okay. Good morning and good afternoon. I'm Xiao Chang Wang. So at this moment, I am in London. It's very early in the morning. So in the next 12 minutes, so I will briefly introduce my idea on water-wise cities, especially the IWA principle for water-wise cities. Next slide. So with these slides, I just say a little bit about the global issues such as climate change, urbanization, and limited resources. So I got no time to say it in detail. Under such a condition, we have to consider the needs for a paradigm shift in terms of resource recovery, livability, and a sustainable system design, especially for water. So that's my idea about the old paradigm and the new paradigm. Under such a condition, about 12 years ago, in International Water Association, we started the Cities of the Future program. So this is the outline of the program. So I unfortunately joined this program from the very beginning. Next slide, please. So as an important output from the Cities of the Future program, we published the IWA principles for water-wise cities. So this picture shows us the whole structure of the principle. So I will explain some detail for next slides. You see, we proposed 5 building blocks to deliver sustainable urban water. It includes some new vision, good governance, updated knowledge and capacity, of course, usable planning tools and implementation tools. Sorry, I got no time to explain in detail, but some of my ideas will be composed in the following slides. Along with the 5 blocks, we also propose 5 levels actions. So we have to take for building water-wise cities. So we consider water service. It should be regenerative. We consider new way of urban design to build our city to be water sensitive. So we have to consider the connection of our city with the basin. And more importantly, we have to consider the participation of all people to form what we say a water-wise communities. Next slide. So anyway, to achieve our common goal, we are facing various difficulties. Yeah, for example, here, I would like to mention water shortage, water pollution, urban flooding, and the imbalance between urban infrastructures, with water. And more importantly, the unfavorable living conditions, including poor urban ecology. Next slide. So in my idea, so what's the main reason for these problems? I'd like to point out that's because up to now, we are using what we say the conventional methodology of urban water system design. So here, so I show you the characteristics and the adaptable condition. What I want to point out is the conventional system, the way we design it, no longer meet the requirement nowadays. Next slide. So with this slide, I want to show you my idea on the direction for change, or what I mentioned already, a paradigm shift. So we should move from the engineering dependent system to a new system. I think the characteristics is engineering in the nature. So I have to say, with the IWA principles of water-wise cities, we considered the solutions to solve these problems. Yeah, for example, we consider integration of urban systems and services and the provision of alternative resources. So that's systematic solutions. We consider urban water and energy saving, resource recovery, and the provision of sufficient water space. So that can be useful for water shortage and flood control. In turn, next slide. So we consider watershed management and source protection and the utilization of new materials. It can help water pollution control. We provide visible urban water, enable regenerative water surveys, and water-related resilient urban design. It can help us to find countermeasures to enhance livability. And the next slide. More importantly, as I mentioned already, for building water-wise cities, we need the participation of people of different levels, including our citizens, our professionals, our policy makers, and also our government or our leaders. Anyway, up to now, in different countries, there are already many successful cases and experiences. For example, in North America, so they practiced low impact development or LID. So here, I just show you the characteristics, main measures, and the main principles, but I got no time to explain in detail. Next slide. In Europe, including Netherlands, so they try to combine water-wise city construction with a sustainable urban drainage system. So that's the main technologies. The main character is to combine drainage system with green infrastructures. So I got no time to explain in detail, but with the slide, so I can show you the example of Amsterdam in the Netherlands, Copenhagen in Denmark. Gothenburg in Sweden, so under Lyon in France, and also in Australia. So they practiced water sensitive urban design, or WSUD. So that's main measures. So with application of these measures, they did a very good practices in several large cities, such as Melbourne, Sydney, and Brisbane. So they face common problems and set common goals, but in different cities, they do things a little bit differently. And now we talked much about China. So you know, so from about 7 years ago in China, the central government proposed sponge city initiative or sponge city construction. So the nationwide undertaking by the central government now practicing in different cities. So here I can mention some examples. They provided these cases to IWA, and on the IWA website, you can find these successful cases. Yeah, for example, the Kunshan Cultural Plaza wetlands, yeah, in Jiangsu province. So the Futian River ecosystem in Shenzhen city, and also the water cycle management for the whole city in the place I used to live there. Yeah, and my university is also there, Xi'an, the ancient city of China. Oh, I mentioned in the beginning, so with a quite limited time, it is impossible for me to explain in any detail about what I talked about the IWA principles of water-wise cities and the successful cases and the experiences in the whole world. Fortunately, just 2 months ago, my book on water-wise cities and sustainable water systems are published by IWA Publishing. Fortunately, they got a support from Knowledge Unlatched. So therefore, this book can be freely downloaded from the IWAP website. With all this in mind, I would like to conclude my talk with several remarks. First of all, as I mentioned already, I said we face climate change, population growth and urbanization, and the increasing demand for resource supply. All these are stimulating a paradigm shift in urban water system design, as what I mentioned. So you can find the detail in my PPT file. Secondly, I have to say, the IWA principles for water-wise cities are not divided by IWA experts, but is formulated on the basis of global experiences, such as what I mentioned, IOID in North America, SUDS in Europe, USUD in Australia, and the Sponge City in China. And the last but not the least, I'd like to say, face all these common and specific problems in various countries and regions. I believe international exchanges are extremely important toward the future. So that's all for my talk. So under the request of the organizer, I agreed to share the PDF format of my presentation to all our audience. So I hope what I talked today can give you the outline of the IWA principles for water-wise cities. Yeah, thank you, Chairman. That's all for my talk.
Thank you very much, Xiaochang Wang. And I can say as a follow-up that the link to the book is, you can find it in the chat. The link will also be available from CEWP website, and also together at our website, we will also have a report from this webinar and from the previous webinar as well. You can find the PPTs and summary report from the previous webinar at our website, and also the PPTs and summary report from this webinar will be made available as well shortly from here. We will come back to the observations of Xiaochang Wang in the roundtable in the end. But before that, we still have got a couple of presentations, and next in line is Ken Yan from AVK. Please, Ken, the floor is yours.
Yeah. Okay. Good morning and good afternoon to everyone. And now I come from AVK China, and I'm based in our Shanghai office. And so later I will use Chinese language to make my presentation to everyone, and hope it may be like a cup of coffee to make everybody have some insight of the business of the water. And then let me share my screen first.好，我这边是给各位介绍一下 AVK。其实更多的是，因为我们是中欧水资源论坛，也是 AVK 作为一个全球企业在中国的多年经验吧，将近20年的一个市场经验，对于城市水务基础设施中关于一些长期的效益的一些洞见或者经验以及案例的分享。那么我们会从我们的一个服务理念，包括产品的质量，逐步深化到我们之前也提到过的非收益水的，从经济角度、水资源管理的角度的进一步的长期的一个效益，我们是如何看待的？更落实到作为一个阀门供应商，我们是如何去紧随着市场以及政策以及民生的需求来提供相应的服务。简单介绍一下 AVK。AVK 是一家丹麦的企业。始于1941年，成立到至今已经80周年了，在全球有125个公司，遍布于将近80多个国家。从一个工作室已经成长到将近4400名员工。那么 AVK 也是研发出全球第一台饮用水用的软密封杂阀的企业。那么随着软密封杂阀的开发，我们也逐步的进行了各种工厂以及橡胶技术，以及我们的全球供应链的一个打造，为全球的客户提供相应的阀门以及配套的服务。那么在中国呢，将近是在1998年就已经进入中国市场。那么 AVK 同时为了满足不同的市场细分，包括工业、包括污水、废水以及我们的供水等等领域呢，我们也吸纳了收购了全球顶尖的阀门的企业，为客户提供打包式的阀门的服务。那么水行业作为 AVK 3大行业之一，我们另外2个行业是工业和新兴制造。水行业将会包括供水、污水、燃气和消防，当中供水、污水也是我们今天的主题之一。那么在中国呢，已经有9家公司以及销售公司以及工厂。那主要的生产基地也是亚太最大的，位于安徽省的马鞍山市。也欢迎有兴趣的同仁可以到我们的工厂进行参观。那么最终呢，我们也希望在水的整个循环当中能够提供自己的一份贡献。因为我们了解到，就是说实事求是来说，每一个水是一个民生问题，每一个人需要的是用到水，并且用到好的水。从业主角度，他希望把水管好，那么整个水的输送和管理过程中，阀门是起到一个至关的作用。 那么我们切入到非收益水的这个点，其实在“13.5”规划的时候，非收益水在中国的“13.5”规划当中已经要求希望要降到10%的非收益水，从15%降到10%。那么在任何措施执行之前，我们会要求自己的产品先要提供一个高质量，才能保证整个的设施基础循环能够稳定的运行。这边是一个图表，是我们收集了一些自己在本土的一些项目案例，当然它不能代表所有的一个象征性的意义，但是至少从我们所提供的产品而言，它可以给大家一个建议或者参考。我们比如说，我们有一台闸阀，它是在管道当中使用，更多的是在城市管网中用。在中国，我们买到一台阀门的时候，往往会提供1年到2年的质保期。那么2年过后，我们会看到，往往一些其他的一些产品，它就会出现各种小毛小病或者跑冒滴漏的一些现象，就会产生一些维护费用。而基本上能够连续使用5年以上的产品会比较少的。而 AVK 我们就打造专门的一个品质，坚持了几十年，我们能够提供一个10年的质保，可以使得如果我在10年之后，我们的运用将近是1台阀门可以抵上其他的6台，这个就是一个生命成本周期的一个分析。那么同时，为了保证良好的一个品质呢，我们会在就阀门本身的从橡胶科技，因为它起到所有的密封件都是用我们独有的橡胶钴米所来制造的，包括 GSK 德国重防腐，是为了达到饮用水的标准，包括面对各种恶劣的情况，使得客户在整个使用过程中会发现我们的使用寿命会极其的长。那么这边有一个简单的例子，这2张图片是我们拍摄于位于安徽合肥市的新三水厂，它其实是之前有一个老的三水厂运营了17年之后迁址的一个地方，但是在17年前 AVK 就提供了它部分的阀门产品，连续使用17年没有出现任何问题，然后保证良好的运行。那么在新厂迁建的时候，我们就从原先只供可能20%到30%的阀门，一直到覆盖到它总体阀门采购量的90%，而这个厂的现在的处理量呢是40万吨每天。那么其实我们有一点会引起思考的就是，往往就是说一些高品质的东西，它需要一个时间的积累才能干到它的长效经济。那么针对之前的非收益水，我们会讲到各个高品质，包括一些产品的叠加技术，会使得我们对于水资源的管理，包括特别是漏损这一块，非收益水提供帮助。那么这个模型呢，是我们比较通认的国际水协的我们的漏损模型。之前也有专家已经提到过，有4大方向可以对我们相关的整个的解决方案提供帮助。AVK 也在这4个方向落实到自己能做什么。从资产管理来言，现在我们的每一台阀门的出厂都是带有唯一的身份证，是一个2维码，通过手机的软件的扫码可以定位到我阀门安装的情况，照片的上传。这是为未来业主他为了提高自己的产品寿命，他会有各种的维护的这种巡检也好，包括定期的勘察也好，可以提供极大的一个基础的数据的支持。第2个就是快速抢修，就是任何爆管的时候，我们有相关的抢修的一些部件，以及我们的一些探漏装置。我们有很多探漏，包括超声的各方面，它可以跟我们的阀门的阀轴延长杆进行连接。因为在很多中国的管网当中，它都是埋地的，往往就是一些阀门呢，它是有阀门井，是可以跟一些探漏装置进行结合的，便于我们进行一些漏损的探测。而压力管理有很大的不同，就是在中国，因为它的人口比较大，它所有的城市管线会随着城市的进步，它的会直径越来越大。我们常规可能有300口径的管道，现在1米口径或者1.5米口径的都是很常见的，所以应对 老城市和新城区不同的管网口径和压力的管理，我们会提供减压阀或者调流阀这一类的控制性阀门，去调节片区的压力，那么降低我的爆管频率，同时延长你本身的管道使用寿命。这是我们一个海外的案例，它是总共是预计是使用500台的减压阀。减压阀顾名思义就是降低管网或者片区当中的压力，但是它的压力末端是达到我们的服务要求的，就是每个人打开水龙头的时候，它是可以保证正常的使用的。那么最终在一期的时候装了235台以后呢，这是能耗以及爆管风险以及节约水量的数据，可以明显到这是一个更加验证我们实际的手段减压控制片区的一个实例。在中国其实已经逐步的开始使用了，但是不如海外会这样大片区的使用多。那么同时呢 ，AVK 我们也提供了这一个称之为压力控制室，它往往是在于 DM 片区的入流口设置的这样一个整合式的，包括各种仪表、减压阀在内的一个预制的，我们称之为中国可以称之为阀门井，来调节片区的压力。在我们的实际情况当中，我们会想它是不是会在 OK， 实际我们会想是不是它会在城市的管网当中用的多，但是随着现在发现，它会在农村的水环境治理当中用的多，因为它的末端建设相对没有达到比较好的条件。那么这样一个具有保护的作用，同时集成各方面的控制作用的一个 chamber， 它可以为农村饮用水提供良好的片区调压，同时它的使用寿命也远大于一般的产品。这是它的一个内部的构成。包括我们海外呢，它就是根据丹麦的纳兰斯市，我们也有相关的案例，可以从落差40米的高处和低处，通过减压片区来提供服务。那么最后我们要想讲的就是一个长期效应，我们往往是看不到的。那么中国14.5包括远景当中提到了数字化，数字化是可以把所有的产品的信息状态进行一个平台的整合。那么其实可以从一定角度来说，本身我们可能只关心压力、流量，但是你产品本身的性能，它更多的都会进入到平台。你可以在最短的时间内去判断产品的好坏和未来的使用寿命以及长期效应，最终纳入一个整体的平台。所以我们也倡导了智能化，是帮助水务公司去解决问题，不是每一样东西都是智能，而是要把做管理的方式变得更人性化、更简易。最后呢，我们也要承诺，就是所有的一个像非受益水呢，就是需要高品质的阀门泵，包括我们要有做到水利模型，包括良好的计价方式，要各个供应商、各个政府部门的联调，才能实现这一目标。OK， 这就是我的一个整体报告，比较快。如果有问题的话，大家可以继续沟通。OK, I have finished.
Thank you very much, Ken, for this presentation. We will move on to the last speaker before the roundtable, Mr. Agostinho Avanzi from IWS. Please, Agostinho.
Yes, good morning and good afternoon to everyone. I'm Agostino, civil hydraulic engineer based in Italy. Let me share the screen. Okay. So I am going to introduce you about IWS, talking a bit about our experience in urban water efficiency. So IWS is an Italian business network established almost 8 years ago. And it's composed by 3 companies. The first one, BM Tecnologie Industriali, is an industrial company providing and supplying instruments for network metering, flow and pressures measurement and level and velocity measurements into the water supply and wastewater network. Hydrostudi is the engineering consultancy company, so it is the engineering company of the business network, providing optimization of water supply and sewerage network. Last, CEWP Water Venture is the leak detection company that is the official distributor of Utilis from Israel for the leak detection from satellite imagery. So these three companies cover the entire urban integrated water cycle, starting from the water abstraction, going through the abduction and distribution networks, collection by means of sewerage and wastewater networks, and finally treatment. So concerning BM Tecnologie Industriali is the first Italian recognized leader company in providing water flows, level, pressure, and quality measuring instruments, in short, medium, and long-term monitoring campaigns in sewerage and water networks, in offering engineering solution for the reduction of no-revenue water losses, extraneous waters into the sewerage system, I mean inflow and infiltration processes. The company has a deep knowledge of customer processes because mainly our clients are water utilities. The company provides and develops water and sewerage networks management culture. So the company tries to bring and to share the lesson learned in the past to the future generation as well. And the company provides also a development of a worldwide distribution networks as well of their instrument and equipment. Basically, the project is capable, the company is capable to deliver a turnkey project, starting from the project management and development, installing, maintaining and removing the measurements, sensor and equipment, and of course, analyzing the data collected. Some examples of our products. So in this slide, I'm going to share you only the information concerning the water supply network. So the company can provide and can supply instruments for water losses management. In this case, in this slide, there is a description of our multifunctional data logger Beyond for water cycle in long and short-term monitoring campaign with the ultrasonic transit time flow module as well, and pressure module as well. The company not only provides the equipment, but also provides the full service for the installation and maintenance. Some other instruments, so ultrasonic transit time flow meters, cross correlation ultrasonic flow meters, and electromagnetic flow meters as well for no revenue water management and district meter areas design. This is how our system works. So after the installation of the flow and pressure loggers and flow and pressure meters, they are automatically connected by means of GSM or GPRS to our computers and storage areas, and then by means of mobile application or desktop application, we can analyze and monitor the networks in real time. As told you before, the company is the leader in Italian water market, and our main clients are water utilities, starting from North Italy, so from Milan, going through the central Italy, so Rome, and then finally closing the cycle in Sicily and the Sardinia regions as well. This is a case study realized a few years ago concerning a couple of highly urbanized area in northeast part of Italy. where we have the biggest industrial areas and commercial areas as well. So what we have done, we provided water losses management with the design of district meter areas in order to reduce the no revenue water. What we used a combination of hydraulic engineering, mathematical modeling. We installed high efficiency devices, and of course we installed our application that is called WaterGuard. That is a software that can be installed in a mobile application or desktop application to monitor and to manage the network in real time concerning the water losses. Basically, the annual savings estimation was about 2,000 megawatt per hour in terms of energy saving. But also another benefit of the project was the reduction of 800 tons of greenhouse gas emission. Concerning the engineering company of the group, it's called HydroStudy, and it's a small medium enterprise at European level. So we are almost in 50 engineers. The company is in line with the quality management system, the environmental management system, and of course, last but not least, the occupational health and safety management. Our approach is the following. So a world in which water challenges are no longer a barrier to an inclusive, sustainable access to water, looking at the most cost beneficiary action in water supply and wastewater systems. We believe that providing services that help to improve the water infrastructure efficiency and resiliency by reducing water leakage and increasing the reuse of treated wastewater. We are in line with the global, all our projects are in line with the global agenda of the United Nations. Our systems and our products are and studies are in line with the International Water Association guidelines, so the EWA guidelines, and the World Bank guideline as well concerning the no revenue water management. Our office is based...
Last remarks, Agostinho?
Excuse me?
The last remarks, time is up.
Yep. So let's move to our system applied to a real case. So our system is called WaterGuard and has been applied to the rehabilitation of Malatya water supply network in Turkey. We are talking about 500,000 population. We provided a master plan for a short, medium, and long-term reduction of the no-revenue water by means of hydraulic modeling and by means of installation of flow and pressure meters within the network. So we analyzed almost 3,000 kilometers of network, and we have been capable to pinpoint almost 200 leakage with a saving of 110 liters per second per day. Last service that we can provide is based on the satellite imagery.
Agostinho, you have to end now.
Yes, so let me just say that by means of satellite imagery, we can cover by satellite imagery, we can cover the information of a water supply networks by means of pre-localized the supposed low water losses. Then we move on the ground for localize directly the losses and then repair the losses by means of our engineers. So thank you for your attention.
Thank you very much, Agostinho. Difficult task to cover so many companies, but an interesting case with your cooperation. And now we have had a lot of very interesting cases. I would like to invite the speakers to join me for the round table. And while we get you up with your screens ready. I can say that, again, all the PPTs and a summary report from the webinar will be available at the CEWP website. Also, Xiaojiang Wang's book will be available there. I would like to draw the attention to the chat. There has been questions posed to Professor Wang and to IWL. So please have a look at the questions and answer those there. Final remark is, it is of course also always sad when you hear so many interesting presentations that it's not easy due to the webinar format to ask questions or to approach the speakers in the next coming break. We will hope that at least some of you will be able to attend when we organize physical site events at Aquatech Shanghai. And we also hope that a lot of you will be able to attend when we have the IWA World Congress in Copenhagen in September next year. So moving on to the roundtable, I would like to ask, the first question I would like to pose will be to Yanqiao Xu and Xiaojiang Wang. We already, during the presentations here, about several challenges, increasing water demands, increasing population, and so on, but also climate change. Are we actually preparing sufficiently for the impact of climate change? Or will we be taken by surprise in 10 years from now? How much the impact will actually be? Should we spend more time on the scenarios and look ahead and start preparing already now? And please give short answers. Xiaojiang Wang, will you start?
Okay. So as I talked, so I think we are not prepared at all. Yeah. So globally, for many countries, we face problems. We discuss problems, but we are not well prepared. Even some country, including my country of China, so they say they are taking so many measures, but I don't think they are well prepared. So this is my short answer to your question. So I saw on the screen, somebody mentioned the slide I used may not be updated. Yeah, because just now when I talk, I just looked at my arm screen. I didn't see the shared screen. So if that's not correct, I've already sent my file in PDF format to the organizer again. So if you want, you can contact with the organizer for the file. So I saw here also one question from Dr. Zhu Liang Liao.
Yeah,
so
Professor
may I
Wang,
answer now or
Professor
later?
Wang,
Yeah.
Professor Wang, I will ask you to the question in the chat that you answer in the chat.
Oh,
and
okay,
then we
okay,
go
okay.
on to hear Yuan Chao Shu. Are we sufficiently prepared for climate change?
Sorry, can you hear me? Okay.
Yep.
I think that we are, but not sufficiently. Different countries, they have their plans toward climate change, as well as China, but we still need some time to first measure and the risk, and then think about measures. So currently, I think people's awareness about climate change has been raised, and the situation is getting better, but currently we're still not sufficiently prepared, but we are going towards that.
Okay. On to Louis Faisca and Agostinho Avanzi. Do you think Do you think that the solutions we have, are the solutions good enough, or should we also look into even further innovation in order to address all the challenges? Louis first.
Well, unfortunately, I think we will never be prepared because climate changes have been more stressful for hydric resources, and the pace that they are carrying out to we have not anticipated. So a further research is extremely necessary and urgent.
Okay, Agostinho, the solutions, are they sufficient?
Not at all. We have been struggling, and we are struggling in projecting the results of climate change in 20, 30, 50, 100 years. We are realizing, of course, that the temperature will increase, water demand will increase, but we will not have enough water to address all the needs. So in my view, we are quite far to a confident solution for concerning the climate change resiliency. But I believe that we don't have to wait our government. We have to do something by our own. I mean, we have to change the mentality of the people and the population instead of waiting the government direction. The governments will do their best, okay, because it's a balance between business, of course, and natural resources. But people and inhabitants can create their better environment based on sharing the lesson learned in the past and increase increase a proper development in our brain concerning the climate change.
Thank you. Østen Egengren, you mentioned your test facility for integrating wastewater treatment with energy and resource recovery. And that means a lot of cross-sector efforts. Will we have the the technical staffs of utilities, will they have sufficient competences to cover this integrated approach? You're based in Sweden, an advanced market. Do you actually see that all of the utilities are ready in terms of competences to deal with these integrated solutions?
Thank you for this question. I think answer is no, because this area, at least in Sweden, we have problem to attract people with good education. And also we must change the agenda as it is now. If you're running a sewage wastewater treatment plant, you are asked to reach a specific quality of the outlet water, but you are not asked to produce energy from the biogas. You are not asked to treat the water to a quality that it can be used for someone else. So I mean, we must change mindset in that way, that we should establish geographical areas, water basins, where you say, how can we get enough water for cooling, for industry, for farmer, for citizen? What is needed? So we need better harvesting system, but we also need a new way of handling the water. To establish better online understanding, we need digital sensors out there. So I think knowledge is one thing, but the problem to be solved must be arranged differently, because we are talking about water shortage in areas, but we are planning for a sewage wastewater treatment plant, for an industry, for the farmer, and so on. And to be able to find a solution for everyone, we must set up the goal for the areas. And we are far away from that. It's a long tradition of organized differently. So I think that is the main purpose. And then the skills in the companies, I will say you need new skills for water reuse. So that is necessary, but you also have to rethink from the organization point of view. I think that is the most important thing. And then, as said before, nature can be more involved for the water harvesting and for taking care of some of the wastewater, and also to have enough of the water. But at the same time, I'm also a bit optimistic, because being set under pressure, people find way to solve problems. So it's possible in my mind, but we must rethink a lot, and we must also integrate much, much more than we are doing today.
Thank you, Øystein. Going to the concrete case of non-revenue water, I would like to ask Ken Jan and Søren Carsten Nielsen. You have presented some quite convincing cases that water leakage reduction is technically feasible and even a good economic case. On the other hand, I do sense at the same time that there might be limits to if the market is actually requesting these solutions. Despite we have areas with water scarcity, the request at the market for leakage reduction, and maybe also barriers in terms of economic conditions are not favorable for non-revenue water. As Søren said, and also asked by Fenyuan, it's more relevant to invest in pipes instead of non-leakage. So what is the problem with the market? Why don't it request these solutions, which would give much more water very, very quickly? Ken first.
对于管网来说，其实它有一个区别，就是城市新城区和老城区。如果在中国的话，我们知道，如果降低一个非受益水，你把基本的管网老的都替换掉，它是没有问题的。但是到现在阶段，已经不会有大批量的去替换这个管网，因为它是随着城市建设来的，它会涉及到许多其他的方方面面，不仅仅是管道。所以在我的演讲当中，我也提到了，其实我们非受益水是在已有现状的情况下，你有新管网和老管网的情况下，用合理的方法把现在的非受益水平进行提高到一个经济水平，比如说从15%降到13%，我们有各种各样的方法，没有一个地方可以保证我所有的管网都是新管网。就像哥本哈根一样，它有很多可能是60年、40年不同年代的管网，但是它还是有自己的方法去降低它的漏损。这是我的一个理解。
Okay. Søren, why don't we see the markets requesting NRW projects more?
To be honest, I don't know, and I don't understand it, because investments in NRW projects is very useful for the water utilities. I think we have a lot of tradition, history. We have strong departments in the water companies that are doing this change of pipes, and the two things should not be one or the other. It is possible to start the NRW journey at very small investments, and it requires a lot of organizational changes. It will take time, so I can only recommend that you start in the small, and then it will increase gradually. But maybe we need more, or not maybe, it's for sure, more information and about it is required.
Thank you, Søren. Coming back to Xiaoqiang Wang and Yuan Xiaoshu, we have discussed the need for paradigm shifts, and we have discussed the situation here when looking across technical solutions, economic framework, and so on. It's quite a change probably required. What would be the organizational changes which would be necessary to drive the paradigm shift? Xiaoqiang Wang first.
Okay. So nowadays we talk about the paradigm shift, but in my opinion, it's really very difficult. So, you know, up to now, including in the IWA Cities of the Future program, so we discussed the technical measures, but I agree with you. What more important is the organization or management of the paradigm shift. Yeah, for example, in China, so we have the movement of smart city construction, but how to do it? So we just follow some successful examples. How can we consider the economic factor and also the cost-benefit analysis? Up to now, we accumulated no experiences. In terms of these, I believe from now on, each country, each international organization, so we should bring people together, not only the water professional, but also the manager, so the decision maker, policy maker. So we have to talk in a larger scale, so not the very narrow field. So that's my idea. So that's also my purpose to talk in this this meeting about the IWA water-wise city principles. Yeah.
Thank you. Yuan Xiaoshu. You need to put on your mic.
Okay. Please correct me if I understood it wrongly. The thing is that, are you asking the organizational change to the paradigm change?
Yes,
Like,
and also based that you're making a lot of very comprehensive analysis, and comprehensive analysis to be taken up needs organizations which corresponds to the degree of comprehensiveness.
Okay. Well, currently it's very difficult, but for example, for different countries, I believe they have they've made certain efforts to do that. Like, for example, for China, and I think in 2017, and they've conducted their ministry reform. So previously, for water issues, there are plenty of departments which is in charge of water problems. And after the ministry reform, there are only 3 ministries and 3 departments that deals with water issues. For example, ecological and environment ministry and water resource ministry. And the NDRC department, but local NDRC. So the government is trying to have a comprehensive, holistic solution on water issues, but it is very difficult in practical. For some of the problems, they have to gain efforts from the help of different provinces. But currently, I would say that in China, and they're trying to think about a comprehensive solution, but still it's on the way, and there's a long way to go. And for some of the problems, for example, it's not only by city, by administration boundaries, but they also have a basin boundaries. And China has both administrations on both level, both on like city level or provincial level and on basin level. So sometimes they would just fight against each other. but now the river chief system kind of solved some of the problems. Like they have a river chief in charge of each river or each lake. So the river chief is in charge of coordinating all the issues regarding this river, like the water quality and the water flow and the water use, blah, 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 blah. So the river chief is the person in charge. And if, for example, they need different two provinces need to work together, or two departments need to work together, the river chief will coordinate all the stuff. And the river chief is very powerful. It's usually the number 1 or number 2 person in that province. So this is a good solution in my opinion. And but still, it's only I think 3 and 4 years, and we will see, like in probably next 5 years, how it goes for the whole water situation in China.
Thank you very much, Yuan Xiaoshu. Time is slipping up. I would like to ask each of our 7 panelists to come up with one single, very brief recommendation which we can eventually further. It can be a recommendation about standards for the design of tenders. It can be recommendations for getting water and energy pricing right. It can be regulatory changes. You're free to choose, but please come up with one recommendation top of mind which can address the topics we have discussed today. Østen, will you please start and brief?
Yes, short. I think the main problem in my mind is to connect the silos. And the most important is to connect the water supply with the water treatment, not seeing them separately, but connect them. And then all the other areas must be connected. That is my best advice.
Integrated water cycle management, can we call it?
Yes.
Louis Fialska, your recommendation.
Well, I have to agree with the with the recommendation from Hosten. We reuse, and we must all individually incorporate our need to conserve and to reuse and reduce the water usage.
Thank you. Agostinho, your recommendation.
I would add not only integrated as much as possible the systems, but I would also add integration among decision makers.
Thank you. Ken Yan, your take?
我们更多的是其实希望企业能够更多参与地方性的行业标准的制定，因为它现在不仅仅只限于国家的企业，其实各行各业的企业都可以参与。这样的话，你可以了解政策的导入，它其实至关重要的。OK。
Local standard setting. Thank you. Søren, what's your suggestion?
Yes, I would recommend that the central part of China, where they come up with very good titles about reduction of non-revenue water. They would follow it up with action plans, asking for action plans from the cities, and showing that they will be able to meet the goals set by the central government, and that these goals, these action plans should include proper calculation of the economics in the projects for piping and the projects for non-revenue water, as for instance we showed here in this presentation. So it will be more focus on other possibilities than making new pipes in the areas.
Thank you. Xiaochang Wang, you'll get the last word of the roundtable. Your key recommendation, brief.
So my key recommendation is still what I talked many times. We have to remember one water. So that means for water that can be useful no matter where it comes from. if it can be useful. So we have to use it. And before that, we have to consider how to use it. So I believe that's still the first problem we should solve. Yeah,
thank you very much.
Yeah.
Thank you to the panelists and to all of you and to the listeners. We will draft a summary report. We will circulate it among the panelists, and you're very welcome to extend your remarks here. Example given the one which came up from Kenyan about local standard setting, a topic we have not touched so much upon, but which is very important to decide what the tenders at the local markets looks like. So please make use of this opportunity to everybody out there. Make use of the materials available at our website. Before we close, I will invite Editor Hogenberg from Aquatech Shanghai to very briefly say a few words about this upcoming expo. And after that, I will invite Liam Jia from the EU SME Center to very briefly say a few words about the services of the SME Center. Both of these things are also, you can find information in the flyer which have been circulated and which can also be found at our website. So once again, thanks to the panelists. Editor, a few minutes about the Aquatech Shanghai Expo.
Yes, good morning, good afternoon from Amsterdam. My video is not working. Can the host, Aleid, can you maybe start my video? Yeah, thank you. Well, hello from Amsterdam. Well, we are really pleased that we are able to support this interesting webinars of the CEWP. Thank you to all speakers as well, because the mission of Aquatech is providing a valuable global platform for international water-related organizations and to contribute to solve the global challenges. So, so this is definitely one of the activities that we want to be involved in. But I would like to invite you all to continue this interesting conversation at Aquatech China. That will take place from the 2nd till the 4th of June. So if you are living in China, then we are looking forward to welcome you. We will also host, together with the CEWP, a seminar. So to continue this discussion. And we also have an interesting industrial water leaders forum that will share knowledge about the water carbon nexus for a sustainable future. And of course, we hope to welcome you in person, the Europeans especially, at Aquatech Amsterdam. And in the meanwhile, you can follow our online newsletters via Aquatech Trade. Thank you all and hope to see you at next webinar again. Thank you. Bye-bye.
Liam, please.
Good morning, everyone. I'm going to quickly share my screen. Actually, good afternoon from Beijing. I'm going to quickly introduce about the EU SME Center and how we partner with China-Europe Water Platform and eventually how we serve the businesses for exporting activities to China. We are a EU-funded program managed by DG GROW and IASME. We have been in China for more than 10 years. Now, currently, we're in the 3rd phase of the project. We are implemented by 5 chambers of commerces, where you can see from the bottom. And we are very happy today to have Agostino representing the Italian chamber participating to this session of the webinars. What we do is to provide services to increase the knowledge of SMEs on their awareness to China and to eventually support in their trade and investment activities with China. All our services we provide free of charge for all European SMEs. that includes a comprehensive range of market reports. We also provide first-line advice for free, and a couple of trainings, both online and offline. Eventually, we also have an advocacy platform where we constantly voice to the Chinese government authorities on improving the business environment for European companies in China. Some examples of the publications we had on the environment sector, and we try to cover as many as possible sectors concerning export activities from Europe to China. And these are some examples of the efforts we have in the water sector and related sectors, including the publication, the reports we produced for China-Europe Water Platform last year on industrial wastewater policy review and opportunities for two of the regions in China, in Sichuan and in Shandong province. And these information are all available on our website. Some examples, again, of how we provide our services for businesses and how we are offering complementary services from CEWP. I noticed that we have an excellent lineup of speakers that includes research institutes, think tanks, but also specifically for businesses who are eyeing on the Chinese market. You are more than welcome to reach out to us at the USME Center. And eventually, there are 2 more webinar series we are organizing in collaboration with China-Europe Water Platform and hereby Amsterdam. And eventually, there will also be physical side events and participation to Aquatech, Aquatech Shanghai of the SME Center, where we will represent the businesses, and more details are going to be announced very soon on both platforms of SME Center and on the China-Europe Water Platform communication channels. And that's very briefly about the SME Center.
Thank you very much, Liam. We are getting into the very final minutes. I will just invite you to take part in the next webinar, which will be on April 29th. And on that one, we will be talking about smart water management, digitalization, considered by many, in particular myself, as the best possibility actually to deal with all the water challenges we are facing. So please hope you have enjoyed the webinar today. Hope to see you again on April 29th, and have a nice day, and thank you for your attention. Bye-bye.